Hello everyone. Good afternoon to all. It's 12, right? Okay. So how was the exam gone? Board exam कैसे गया सब? Okay. I hope everybody did well in their board exam. Okay. Now, now we'll focus on JEE Mains 2, right? Which will be starting from 6th of April. Is that enough? Is it enough? Yes. So for that, we have only 10 days, right? Tell me, as today is 23rd, and our exam is starting from 6, right? 6, so 5 plus 6, 10 days, mostly 10 days we are having. And within these 10 days, how we will utilize these 10 days? So first, what I'm suggesting you all, so what we are going to do with your studies, or what is the effect Avanti will bring in your studies, that is actually we are introducing the crash course model for the 10 days. And in these 10 days, 5 days will be for your crash course, or we'll revise the some topics, those weightage wise, or those are very much important topics, and you can solve the questions in JEE Mains exam. So those concepts or those chapters will cover with some previous year questions. And then in each of alternative days, there will be an exam of full syllabus test in the first of the class, in first of the day, and in the second half of the day, test paper discussion will be happening. Is that clear to everyone, guys? Okay. So I hope this is clear to everyone. And I hope my voice is clearly audible to you all, and also my screen is visible clearly to you all. Let's start with our topic, that is the first topic, which is mathematical reasoning, right? So what actually mathematical reasoning, the weightage of these topics is very high. Each year in JEE Mains and Advance also, one question is coming. Compulsory, you will get 4 marks if you will study these topics within. If you will give not 2 to if you will give 3 to 4 hours for this topic, then you will solve one question mostly in your JEE Mains examination. Is that clear? Okay, so that's why this topic or this chapter is very much important by weightage wise. Nowadays, in kabhi kabhi to 2 questions also are coming from this topic. Is that or not? Okay. So that's why this topic is very important, and the weightage of this topic is very high. So my suggestion is, let's use this 1 hour with efficiently, and I'm giving you guarantee that you will solve one question from mathematical reasoning in your JEE Mains exams. Okay. So let's start our topic, and let's start our chapter, mathematical reasoning. So what is this actually? In this session, what we are going to cover, let's see. We'll see what is statement, simple statement, compound statements, truth table, all these things we'll see. And you already studied all these things in your class 11th also. Okay. So the thing is, don't think about this topic as an English topic, because there are written statements, simple statements, compound statements. So nothing like that. Actually, it's a topic from mathematics, and we are discuss about the mathematical statements, not about the English literature statements. We are discussing about the mathematical statement. Is that or not? Okay, let's start there. Okay, so what is the statement? What is mathematical statement actually? Let's see. So mathematical statement is the statement which is either true or false. This is mathematical statements. Which statement is either true or false? That is called mathematical statement. Yes. Okay. So you can see here in your screen, you can visualize also. There is written clearly. Yeah. A sentence is called mathematical acceptable statement if it is either true or false, but both not. At a time, they can't be true or false. Okay, it can be either true or it may be either or false. Okay, okay. So a sentence which is an exclamatory or which an imperative or an interrogative cannot be a statement. So simple, don't bother about all these things. I just talking you or I just telling you, remember the statement which is either true or false. That is called mathematical statement. So some examples we can see here. Suppose we are taking example 2 plus 2 is equal to 4. This statement is true. Okay, this statement is true. Then it is called, what is it is called it is called a mathematical statement. Then the second example, you can see here the sum of two positive number is positive number. Sum of two positive number is always positive. Yes, this is also true. So this is also a mathematical statement. Okay. And the third example says all prime numbers are odd numbers. Is it false or true? All prime numbers are odd numbers. No, all prime numbers are not odd numbers because 2 is an even number. 2 is an even number which is also odd. Sorry, which is prime. So this statement is false, but it is a mathematical statement, right? It is a mathematical statement because the statement is false, but it's a statement. Okay, because the truth value of this statement is false. Actually, what is truth value? Truth value is whether if the statement is true, then we are writing here T. So T, this is the truth. True is the truth value of the statement. If here in the third example we are getting it's a false statement, then the truth value of this statement is false, right? So this is all about your truth value, right? So let's move to the next thing. Now in your screen you can see another 3 examples are there. You have to choose where whose are the mathematical statement or not. So if we'll see the first examples, 2 plus 2 is equal to 4. We have discussed all these things. Huh? So the first statements, the first 2 statements, okay, then be my race. Okay. So see, 2 statements, the first 2 sentences are true, but the third one is false. This is true, and this is false. So, but these 3 are mathematical statements. Why? Because these statements are either true or false. They can't be both. Okay, there is no exclamatory interrogative sign also, right? So this statement is true, this statement is true, this statement is false. So false, whenever also the truth value of the statement is false, that is also a mathematical statement. Remember, when we can say mathematical statement, when the statement is either false or true. Clear? Sure, let's move. इसमें कुछ नहीं है, बहुत easy question है. Questions: which of the following statements are sentences are statements? So you have to choose which of the following are mathematical statements. Okay, so let's see. Sum of x and y is greater than 0. Yes, it may be true, it may be false. It does depends upon the value of x and y. So it may be true or it may be false also. Okay, so we can generally say this is false. It is always not true. Na? It is always not true. Sum of x and y is greater than 0. If x is a negative number, y is another negative number, then their sum will be negative. Okay, they can't be greater than 0. So this statement is false. So it is a mathematical statement. 3 plus 4 is 6. No, it is false, but it is a mathematical statement. Yes, because the truth value of the statement is false. Third one, all prime numbers are odd. All prime numbers are odd. It is false also. We have discussed it, but it is a mathematical statement. Every set is finite. No, it is false. Every set is not finite. It is false. It is also a mathematical statement. Oh, it is mathematical statement? No. Why it is not? So you can see here, we have mentioned here a sentence which is an exclamatory or a which or an imperative or an interrogative cannot be a statement. Okay, so it's a question mark question. Okay, so is every finite, if every set is finite, it's not a statement actually. Okay, and may God bless you. Whether may God bless you or not, this is not a mathematical statement actually. The sum of two negative number is negative. Sum of two negative number. Sum of two negative number is also negative. It is true and it is a mathematical statement. Is that clear? So this is all about your mathematical statement. Let's move to the important thing. Okay. Now we'll start the statements. What is simple statement? Okay. So a statement is called simple when it can't be broken down into two or more statements. This is very simple. Simple statements is simple. The statement which can't be break down. ठीक है, जिसको हम तोड़ नहीं सकते, है ना, जो स्टेटमेंट को हम तोड़ नहीं सकते उसको हम क्या बोलेंगे, सिंपल स्टेटमेंट. Okay, so simple example I have written here. 11 is an odd number, right? 11 is an odd number. It's a simple statement. It can't be broken. Can you break it? No. So this is simple statement. Okay. Okay, let's see. Now, compound statement. What is compound statement? So actually, two statements, two simple statements connected by and or. Then what is the statement you are getting? That is my compound statements, or we can say a statement which is made of two or more statements is called compound statements. Okay. And statement which form a compound statement are known as its components. Okay, इसमें कुछ भी नहीं, ठीक है. So if we take two simple statements and we'll connect them, then what is the statement you are getting? That will be a compound statement. Is that clear? And those two simple statements are called the component of the compound statement. Is that clear, everyone? Yes or no? So fine. If here we can take an example here. See, 2 is a prime number. 2 is prime or it is even. So what are the components here? One component is 2 is prime. 2 is prime. Yes. Square of an integer. One component is 2 is a prime number and 2 is also even. These are two components. Yes. Similarly, the second thing, square of an integer is positive or negative. Square of an integer is positive or negative. So what are the components here? The square of an integer is positive. Square of an integer is positive. And second components will be square of an integer is negative. These are two components you will get from the compound statement. Okay, so let's move. This is all about your compound statement. What is truth table? Truth table is actually a table which shows the relationship between the truth value of compound statements and the truth value of its component statements is said to be the truth table of compound statements. That means if you have a statement, suppose I am taking one statement, and statements are generally represented by PQR. Suppose I am taking P is one statement, Q is one statement, R is one statement. Okay, so here I am taking one statement that is P, which represents number of rows is equal to 2. Suppose I am taking a simple statement. Anil is the top ranker of his batch. Okay, so this is actually the statement P. Okay, so simply the statements are represented by the PQR. So what are the truth value? Truth table of a statement, a single statement. If you take a single statement, suppose I'm taking P, 11 is an odd number. Okay, if 11 is an odd number, this is my statement P. So what are the truth value of P? So suppose this is P, then it may be true or it may be false. Either it is true or false. है ना? So truth table क्या हो जाएगा? What is the truth table of a single statement? If you have a single statement, then suppose you have a single statement P, then the truth table of P will be, it may be true or false. So this is the truth table of a single statement. Truth table of a single statement. Okay, done. So similarly, if you'll have two statements, suppose here I am taking 11P as a statement. 11 is an odd number, and Q, another statement I am taking, 11 is also 11 is all 11 is a prime number. Okay, so these are two statements. So what are the possible truth values of these two statements P and Q? Let's see. So either at a time both the statements will be true. Then if one of them P is true, Q is false, there is another possibility. If P is false, then Q is true, then another possibility is there. And if both the statements, a possibility is there also when both the statements are false. Yes or no? Is that or not? Clear? So remember, when you have two statements, the truth table will be like this. Remember, all of you, please. This is important. You have to remember this truth table. Okay. So when you have two statements, I am telling you again, when you have two statements, then the truth table will be like this: true, 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 false, false, true, false, false. Okay. Remember, true, 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 false, true, 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 false, false, true, false, false. Okay. This is the truth table of two statements. If you have three statements, normally 60% questions are asking with the two statements. If you are unlucky and your luck is not good, then you will get a questions with three statements also. But it will be lengthy or it will be taking time, right? Okay. So let's see. If you have three statements like PQR, right? So what you will do? What are the possibilities? True, 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 false, true, false, false, true. So पहले तो ये करो. First write for P, then Q, then R. Okay. So for P, write T, 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 T. 4T, 4F. Okay. Then for the Q, true, true, false, false, true, true, false, false. Then for the R, T, F, T, F, alternately, T, F, T, F. Right. Remember like this. For P, first write 4T, then after write 4 false. For Q, first write 2, 2F, 2T, 2F. Then for R, TF, 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 TF. Okay. Done. This is for your when you have three statements. Now we'll start with the connectives, logical connectives or logic connectives. Okay. Okay. The words or phrases which combine simple statements to form a compound statements are called logical connectives. That means by using some connectives, okay, by using some connectives, we can make simple two or more simple statements as a compound statement, or we can say simple statements are connected by some connectives to make compound statement. Is that or not? Yes. So like from those connectives, one is and, second one is, first one is we'll discuss about and, second one is or, and third one is if then. If P, then Q. Okay, if P, then Q, right? If P, then Q. And also fourth one is if and only if and only if Q. Okay, so the symbols are for and we have symbols as like this, and for or like this. Okay, so if you have two statements, if you have two simple statements P and Q, you can write P and Q as this. And if you have two statements, you have to write P or Q, then you can write this. So and connectives is called actually conjunction, and or connective can be called disconjunction. Okay, and is same as conjunction, and or can be called disconjunction, right? Simply, if then statement can, if then statements go, we can denoted by, or you can represent a statement like this: P implies Q. Okay, P implies Q. This or this, or P implication, or P conditional Q. Okay, or also you can write this way also. Okay, so this is my implication or conditional. We are talking about the symbols only first, then we'll move to the actually the questions are coming from these topics are very simple, right? Only in 2021 some questions are asked, those are tough questions, but if you understood the concept very well, then you can also solve this question. Okay, and this concept, this topic is very important because of every year or in each session one question you will get in JEE, and this is compulsory. You will get, I am giving you guarantee, I'm giving you will get 4 marks in your question. So you know, guys, you know, if you are solving 5 questions in the JEE examinations, then you will get 90 percentile. In mathematics, if you are solving 4 to 5 questions from mathematics, then you will get, or then you can score above 90 percentile in mathematics. So if you are solving 8 or 10 questions, that means you are getting 99 percentiles. Understood? So we need to select some topic from where we can solve the questions in JEE examinations. So that is actually important. Yes. Chalo. So let's, this is about my implication or conditional. Then the last one is if and only, right? If and only, that is double implication we can say also, or equivalence or biconditional also we can say. And how we can represent them, the symbol is like this. So P double implication this, or P biconditional Q, or P, if and only if Q. Okay, if P and only if Q. Okay, if and only P, if P, only if Q. If P, only if Q. You can read it as like this. Okay. So this is about all about my connectives or symbols of connectives. Now start from the connectives and oh, we have so very less times and we have completed a lot of things with all the concepts also for the terms. Okay. So the connectives first to and this is don't worry about all these statements, all these things. Okay, no need to study all these things. I'm just telling you, if you have two simple statements, suppose P and Q, right? P and Q are two statements, right? Then this is my compound statements. These are my simple statement. These are my P and Q are two simple statements, and we are connecting these two statements by and or conjunction, we can say also connectives ands. This and means it is represented by this one. The symbol for and is this, or we can say this is also the conjunction statement. Conjunction statement. Okay. And it is the compound statement is represented by P and Q. Remember P and Q. Now we'll go through the truth table of this. Okay. So remember, just very simple thing for the truth table of and or conjunction is actually what is that? See, when both the statements are true, when both the statements are true, then the compound statements of P and Q is true. That means here you can see P is true, Q is true, then P and Q is true, right? Otherwise, always false. If one of them is false, if one of them is false, then the compound truth value of the compound statement is also false. Understood or not, everyone? Okay. Sorry. What is the reason? Yeah. See. Otherwise, it is false. When both the statements are true, then we can say the compound statement is true. Otherwise, it is false. If one of those simple statement is false, then we can say the compound statement is also false, or P and Q is false. Remember, in case of conjunction, remember, note में मैं लिख देता हूं यहाँ पे, if both P and Q are true, then P and Q is true also. Otherwise, it is false. Remember, everyone? Okay. So this is about your conjunction. You can take an example also. You can take P. Suppose I am taking 11 is odd. Q. I am taking 11 is prime. Both if 11 is odd and it is prime, you can combine these two and you can make a compound statements like 11 is an odd number and it is an 11 is a prime also, right? So when both the statements are true, then the compound statements becomes true. If one of them is false, then it is also the compound statement will be false. Is that clear to everyone? Then next move to the connective, the OR. Now we'll discuss about the connectives, that is OR. Yeah. Okay. And it's denoted by V like this. This is the notation of OR disconjunction statement, or we can say disconjunction statements. P or Q, the compound. If P and Q are two simple statements, okay. If P and Q are two simple statements, and if we'll connect those two simple statements by the connectives, or if P and Q are two simple statements, okay, if we'll connect these two statements by OR, then it is called disconjunction, or it is denoted by P or Q. This is also, it can be read as also P or Q. Okay. So what is the truth table? Truth table is very simple. Like truth table is, what is the truth table of P or Q? This is the case when both the statements are false, then we can say P or Q is false. Right? Is that clear? Only one case when it is false, when both the statements are false. Otherwise, it is always true. Remember, in case of disconjunction, when both the statements are false, then the compound statements P or Q is false. Right? If otherwise, it is always true. If one of them is true or one of them is true, then it is also true. Like you can take one examples. All your fathers are staying in Bangalore or in your home. Sorry. Yeah. So you can take another example also. All of your father are from Bengaluru or from your home. So if both the statements are true, either your fathers are from Bengaluru or from your home, or even like say like that. So also all of your fathers are staying in Bengaluru or in your home, or in your native place. Okay, both the statements. If the second statement is false also, if your fathers are not staying in your home, then they are staying in Bengaluru. Right? So if one of the statements, okay, if one of your statement is true and another one is false, then the compound statements which you are getting, that is also true, right? So you can take another example also for you only. Okay, you can imagine all of you are from the district Bangalore urban. Oh no, no, that is not. All of you are from the district Bangalore urban or from Karnataka. Either you are from Bangalore or from you are from Hassan also, you can take Hassan. Okay. So if either you were from Bangalore or from Hassan, you can take these examples also. If one of the statement is true, okay, then other compound statement is also true. Remember, don't bother about anything. The main thing, you should focus on, in case of disconjunction, okay, when both the statements are false, the truth value of compound statements P or Q is false, otherwise it is true, right? You can think about the examples in your home. Okay, don't waste time. Chalo, okay. Now, types of OR. This is not important really at all. So just discuss these things. Okay, so one is or is or disconjunction or connectives. Disconjunction statements or connectives are two types. One is exclusive, another one is inclusive. So what is exclusive or? See here, exclusive or means either one of them excludes the happening of other. Okay, happening any one of Q excludes the happening of other, then it is exclusive. Suppose you are taking P or Q. So when we can say they are exclusive or, we are using the exclusive or, that means both the statements cannot occur together. Okay, both the statements cannot occur together. Okay, so this is actually my exclusive or. It is denoted by actually like this. Using it, see here, denoted by this. Okay, P V niche bar Q. So this is my exclusive or. This is not important at all. Okay, so you can take an example. I will go to Delhi either by bus or by train. Use of or is exclusive here. That means if you are going by bus, okay, if you are traveling by bus, then you are not traveling by train. So if one statement is true, then other will be excluded, other will be false, obviously. Okay, so this is example for exclusive or. And what is inclusive or? If in a statement P or Q, both P and Q can also occur together, then it is inclusive or, right? You can take example here. It's a very simple example. You can have burger or pizza. You can have burger or pizza. This is example for exclusive or. So this is not important actually. So we'll go through the questions first, and this is important. You two guys, you can post a doubt also in the chat box. Okay, now move to the negation. What is negation of a statement? So actually the denial of a statement is called negation of a statement. Okay, denial of a statement. Simple, nothing else. Denial of a statement is called negation of a statement. Suppose you have a P, statement P. Okay, so if you'll deny this statement, if you'll deny that statement P is wrong, okay, then we can say it is negation of P. Okay, denial of a statement P is called negation, and it is written as this. So negation of P, how you can write this? Negation of P. Okay, this is my negation of P, right? Okay, negation of any statement P is formed by writing. It is also written as, it is not the case that P, or we can write it is false that statement P, or inserting the word not P. Not when you have Ram is Good. So this is, if this is P, then negation of P will be Ram is not good. So it is denoted by negation of P is denoted by this. Okay. And what is the truth table of this negation? That is, if the truth values of a single statement is true, false, then negation of P will be true becomes false and false becomes true. Right? This is all about your negation of a statement. Now we'll go through the De Morgan's law. All of you know in class 11th also in the set relation functions, all of you studied what is De Morgan's law, right? So De Morgan's law says A union complement of A union B is equal to A complement intersection B complement. All of you remember or not? Yes. Similarly, another law is there, that is A intersection B complement is equal to A complement union B complement. Okay. So this union becomes intersection here and intersection becomes union here. So in this case also we'll see another things. Some note I am going to share with you. They are actually what I'm telling you, negation. Like this De Morgan's law also, negation operates. How? So we can write this as negation of P and Q. Negation of P and Q as negation of P, and this and becomes or. This and becomes or negation of Q. Right? Similarly, another rule is there, that is negation of P or Q, that is negation of P, and this or becomes and negation of Q. Okay. So we can treat this. Why I'm telling you De Morgan's law? So you can treat like this intersection as and as intersection. For short tricks, tricky. For trick, what I'm suggesting you use this and sign or conjunction sign as intersection and use or as union. Okay. We'll solve some questions, you will understand. Okay. So trick क्या है? Trick क्या है? Suppose, but I'm telling, the दुनिया जो होता है ना, हमारा जो world है, उसको हम कैसे represent करते हैं? How we can represent the world? So that is my universal set. है ना? U. That is my universal set. Yes. So if it is universal set is here, and you have a small set P, or if you have a small statement P, suppose here I am writing P. Okay, this is P. So which is P complement? Tell me, which is P complement? So this is my P. Red line region is my P. So, and which one is my P complement? So this will be my P complement, black shaded region. Right? So all of you remember all these things or not? Yes. So we can say here P union P complement gives you universal set, right? P union P complement gives you universal set, and P intersection P complement gives you disjoint sets or fine. Right? So these are two rules. We know all these things in the set theory. Similarly, here also, by comparing these two, I can say P union negation of P. P union negation of P gives you universal set. That is also we can say true, right? And P intersection negation of P gives you 5. That is also F. We'll discuss about later. Remember, remember these two things. We are just comparing this with the De Morgan's law and the properties of set. Okay, Venn diagram. Is that clear to everyone? Now we'll solve one question. What is that? Okay. This is a question asked in 2020 JEE mains. Okay. So what is the question? Negation of a statement. You need to find negation of the statement. Okay. So it's a very simple question. So you can see how easily you can score 4 marks in JEE mains from the topic mathematical reasoning. Okay, so you need to find the negation of the statement, right? So root 5 is an integer of 5 and or 5 is irrational, right? Root 5 is an integer or 5 is irrational. So what is the negation of this statement? Okay, so what is the negation? Suppose P is here. P is a statement, root 5 is an integer. And Q is another statement, that is 5 is irrational. Right? You need to find the negation. You have the statement like this, P or hai tumhare paas, you have or in as the connective, that means P or Q. So you need to find the negation of P or Q. That is, negation of P or Q is De Morgan's law use karo. Negation of P or Q is negation of P and negation of Q, right? So that means negation of P. So first you need to find negation of P. So root 5 is not an integer. Root 5 is not an integer. Negation of P says root 5 is not an integer. And this or becomes and 5 is not rational. Sorry, 5 is not irrational. So which of the following statement is true? You are getting the answer. Root 5 is not an integer or nahi, or becomes and 5 is not an irrational. So option B is the correct one. Clear everyone? Option B is the correct answer. How easy questions are asking from? You can see na 2020 में ये question पूछा गया था. You need to find the negation of the statement. That means where you are having or you need to just put and root 5 is an integer. Negation of P is root 5 is not an integer. Q 5 is irrational. 5 is not irrational. It's very simple now. Yes. So let's move. Another question. Okay. Now negation of compound statements. Okay, negation of compound statements. Remember, these are the very important properties. Negation of conjunctions. That means negation of, already we have discussed, negation of P or Q. Sorry, P and Q is negation of P or negation. So this and becomes or, and negation will be with P and Q, right? And this is the truth table of negation of conjunction, right? Truth table you can make now. Okay, suppose you are having two statements P and Q, and these are the truth value. So negation of P will be T becomes false, T becomes false, false becomes true, false becomes true. Similarly, Q, negation of Q, true becomes false. Okay, so this is already proof, and now we are going to prove another statement, negation of disconjunctions. Let's start. Negation of disconjunction. Here we need to prove this statement. Okay. So negation of P or Q is equivalent with negation of P and negation of Q, right? Equivalent matlab these left hand sides is equal, which truth values will be given by the left hand sides, the same truth value will be given by the right hand side also. Then we can say both the statements are compound statements are equivalent. Is that clear? Okay. So now we'll prove this by using the truth table. Okay. So P or Q, right? So P or Q. So P or Q. When remember, try to remember what is the truth table of P or Q. So there is only one case when both the statements, when P and Q are false, both P and Q are false, then the compound statements P or Q is false. Otherwise, it is true, right? So search where false are available. False. This is, so this is false. Otherwise, it is true. Right? Now negation of P or Q is negation of P or Q, T becomes false. It is false, it is false, it is true. Yes. Now negation of P and negation of Q. You need to find negation of P. Already we have found Negation of P, that is T becomes false, T becomes false, T, A becomes T, A becomes T, right? Negation of Q, T becomes A becomes T, T becomes A becomes T, right? So now, negation of P and negation of Q. So in between these two, we need to find the conjunction. So remember the table of conjunction, truth table of conjunction. When both the statements are true, then the compound statements P and Q is true, otherwise it is false. So such where you are having both the statements are just true. So this. So this becomes true, otherwise it is false, right? So you can see here, this is my left hand side. This is my left hand side and this is my right hand side. You can see both the statements are having the same truth values. FFFT, FFFT. Right? So now we are proved the statement both this left hand side is equivalent to right hand side, right? So remember, this is the first negation rule for the conjunction, that is negation of P and Q becomes negation of P or negation of Q. Similarly, second one is for the disconjunction, negation of P or Q is equivalent with negation of P and negation of Q. Clear everyone? चलो बहुत कुछ है यार, खत्म ही नहीं होगा. चलो, now we'll see quantifiers. What are the quantifiers? The words, phrases like all, right? All, some, none, there exist are examples of some quantifiers. Okay, so all of you know na, there exist. You must use this term, there exists, right? Okay, so this is our there exist, and for every or for all, what is the symbol you are using? This, right? Suppose I am taking an example for quantifiers. Suppose you have a statement P, which is for all x belongs to R, x square greater than 0. And Q, another, there exists a triangle where whose all sides are equal. There exists a triangle whose all sides are equal. So see, you can see here we are using the quantifiers, right? We are using the quantifiers. So this is my quantifiers. This is my quantifiers, and this is also my quantifiers. Okay, so if I'll ask you to find the negation of these quantifiers, what you will do? Negation of the quantifier. So what you will do? So note, remember, negation of quantifiers. Okay, so first one is, I am telling you, negation of there exists. Negation of is there exist is there is at least. One is there is at least. In place of there exist, we can write there is at least, or there is, or we can write also it is possible to find. Okay, and also find or some. Okay, so these are the negation of there exist. In place of negation of there exist, you can write there exist, at least, there is, it is possible to find, or some, right? Similarly, negation of for all. Negation of for all is actually negation of for all is not all. Okay, not all. Remember, not all. These are the negation of quantifiers. Clear? Clear, everyone? Chalo. Now, oh, we have very less time. I will complete this, guys. I plan to discuss some previous questions also, but thing is, comparison. Okay. Yes, actually my pen is not working. Sorry. Just a minute. Hmm. Chalo, ठीक है. So next thing is now we'll see conditional statements. Okay. So what are the conditional statements? This is actually denoted by okay. Conditional statements are saying like this. Remember the truth table of conditional statement is actually when the truth value of P is true, the first statement is true and the second statement is false. In that case only, the compound statement will be false. Otherwise, it is always true. Okay? Otherwise, it is always true. Remember, in conditional statements, or we can write this as if then. We can read it as if then. If P, then Q. If P, then Q. Right? Similarly, okay. What is happening with my pen? Sorry, guys. Sorry. Okay. Similarly, if we'll go through the next thing that is, by conditional or if and only. So the conditional statement is saying like when the first statement is true and the second statement is false, then we can say the compound statement is false. Otherwise, it is always true, right? Otherwise, it is always true. So similarly, also in case of biconditional or if and only statements, that means we can read that it is written as P double implication Q, right? P double implication Q, or we can write it as P biconditional. We can see double implication also. We can say what is that? Double implication. ठीक है. ओके. चलो ठीक है. ये अगर हो गया then we'll move to the truth table of biconditional, right? So similarly, you can read it as P if and only Q, Q if and only P. If P is true, then Q is true, and its converse is also right. Its converse is also true. P is necessary and sufficient condition for Q, and Q is also necessary and sufficient condition for P. Okay, so this way you can read all these statements. Okay, so go to the next thing: biconditional connectives and if and all. So what is the truth table? Okay, truth table is saying, remember, when both the statements are true or false. Okay, either both the statements will be true or both the statements will be false. Then we can say the compound statements or the biconditional statements, or what is that? If and only if P only if and only P Q, P if and only Q is true. When both the statements, remember, when both the statements either true or false, in these two cases we are getting T. Otherwise it is false. Otherwise it is false. Right? Remember, and how we can break this? We can write this as also P and P implication Q, Q implication P is written as P implication Q and Q implication P, right? Or we can write directly it as this. We can break this as like this. Okay, got it? Chalo, okay. So this is all about your biconditional. Now we'll move to converse, inverse, and contrapositive of a conditional statement. Okay, so what is converse? Converse is P if P then Q, P conditional Q. The converse statement will be Q conditional P or Q implies P. P implies Q. इसका जो converse होगा, the converse of P implies Q is Q implies P, right? Inverse क्या हो जाएगा? The inverse of P implies Q is negation of P implies negation of Q. This is inverse. Huh? In case of inverse, what is happening? P implies Q becomes negation of P implies negation of Q. But in case of contrapositive, what is happening? Remember, P implies Q is defined as negation of Q implies negation of P. Okay, so P, Q are interchanging between themselves. Okay, P and Q are interchanging between themselves, right? So this is all about your converse, inverse, and contrapositive of conditional statements. Now, logical equivalence. Logical equivalence में हम क्या बोल सकते हैं? So the compound statements are said to be logically equivalent or simply equivalent if they have same truth values for all logical possibilities. Okay, like if you have here two statements, suppose one is P implies Q, another compound statement is negation of P or Q, negation of P or Q. See here, if you are getting, first you need to find P implies Q. You are getting the truth values of P implies Q. And here also you are getting the truth values of negation of P or Q. So you can compare here, both the statements are having same truth values. Both the statements are having same truth values. Then we can say both the statements are equivalent. Is that clear to everyone? Both the statements are equivalent if both the statements are having the same truth values, right? This is, or we can say these statements are logically equivalent. Okay, so here you have a question. The contrapositive, you need to find the contrapositive of the statement. If I reach, if I reach the station in time, then I will catch the train, right? You need to find the contrapositive. So what is the contrapositive of this statement? So contrapositive is P implies Q. P implies Q. So what is the contrapositive of P implies Q? That is negation of Q implies negation of P. Okay, so this is my contrapositive. P implies Q is negation of Q implies negation of P. That is, this P is, if I raise the station in the time, then I will catch the train. So you need to first find negation of Q. I will catch the train. Okay, so I will not catch the train. I will catch the train. Negation will be I will not catch the train. Then
If I will not catch the train, then I don't reach the station in time. Okay, so option D is the correct answer, right? Option D is the correct answer, because the negation of P will be, what is that? P will be, I will not, or I don't reach the station in time. Okay, I do not reach the station in time. I do not reach the station in the time. Okay, I will not. The option is D is the correct. If I will not, the negation of Q. Q is here. I will catch the train. That means the negation of Q will be, I will not catch the train. That is, I will not catch the train. Then I do not reach the station in time. So this is the answer for contrapositive. Next, we will go through concept test. ये question homework है तुम्हारे लिए, because we don't have any time now. Okay. So tautology is when a statement, when a compound statement is having all the truth values as true, right? Here you are having a statement. Here you are having a statement P or negation of P and Q, and here you are getting all the truth values of these statements are true. Then we can say it is a tautology. Okay, this is a tautology, right? Similarly, when you are getting all the truth values of a statements are false, then we can say it is fallacy. Remember, when we are getting that all the truth values of a statements are false, then it's called fallacy. Remember, it is called fallacy. When all the truth values we are getting true, that is called tautology. When you are getting all the truth values are false, that is false. Clear? Okay. Next, so negation of compound statements like this, negation of P implication Q. Negation of P implies Q is P and negation of, right? P and negation of Q. You can draw, you can make the truth table also, you can prove this. Okay. Similarly, negation of P double implication is equivalent to P and negation of Q or Q and negation of P. ये तुम prove कर सकते हो. You can prove it by using the truth table also, right? Okay. So now we'll see algebra of statements. First one is idempotent law. P and P gives you P. P or P is P, right? Commutative law P and Q, Q and P are equivalent. P or Q, Q or P are equivalent. Associative law, just bracket ko, you have to change the bracket here. Here the bracket in the right hand side, here the bracket is with P and Q, and here the bracket is with Q and R. Similarly, here also you can see distributive law. Similarly, distributive law, just you need to write this way: P bracket of Q or R. So then the bracket shift to first two. So that is P and Q, or this and becomes to middle, and this inner wala portion becomes the inner wala symbol, or goes to outside. Okay, then this is my distributive law, right? So now De Morgan's law we have already discussed. Involution law, or negation of statement is itself is the statement itself, that is negation of P is P. Identity law, that is if you take identity law, if you take P with universal set, then you will get T means it is tautology or true, or means the universal set, or you are taking, just compare with the straight set. P intersection a universal set gives you PU itself. Okay. Similarly, P intersection with the fallacy, or all those truth values are false, then you will get also 5. Right? Suppose you are taking P outside the universal set, then it gives you fallacy, or C. You can see C. You can write this as C, or also a fallacy. Right? There is no common between them. Similarly, P or T gives you T. P. If this is my universal set and this is my P, this is my P and this is my universal set, then P or T gives you the universal set itself. And for the universal set, we are taking T, and for the disjoint sets, we are taking C or false, A, fallacy, right? So P or fallacy, this will give you P in this case. In this case, P or P complement, or you can take P or P complement. No, P or C, that is false outside the P. This is my P, and outside of the universal set are disjoints. Disjoints. No. P or, that means P or this C or F is gives you P. Okay. So complement law is like this. You can see go through these algebras, and actually these algebras will be helping a lot in problem solving, because we are having we are running out time. We don't have much time. If we'll get time in future, we'll obviously discuss at least 10 to 15 questions from this topic. Those are very much important questions also. Anyway, we have covered all the concepts. Just you go through all the algebra and try to solve all the questions asked in previous year JEE main examinations. You can, I am giving you guarantee, if you understand all the concept of mathematical reasoning, then you will able to solve whatever the questions will be coming in the examinations. You will able to solve. Is that correct? I hope this is not very much a very interactive class, because we have 1 hour and we need to complete 2 chapters in these 1 hours. And my target was actually to complete reasoning with statistics, which is not possible. But what I'm doing in my way, my pen is not working. That's why I am facing some issues. Okay. So for in the next class, I will try to solve more questions about mathematical reasoning with some questions on statistics, and we'll cover some important portions of statistics also, right? And in the next class, we'll start from quadratic equation and complexity. Okay. So till then, bye bye. Take care, all of you. Bye bye. Chalo. I hope all of you good. Chalo.